In lesson 3, we are going to talk about linear equations. And our real focus in lesson 3 is to see how an equation of a line, a table of values of a line, and a graph of a line are all connected. So let's take a look at this first example. An equation of a linear relation, for example, is y equals 3x minus 5. So this is the particular example that we're looking at. This is called a linear relation. Okay? In this case, x is our independent variable, and it is always plotted on the horizontal axis. Remember, the horizontal axis goes from left to right. So x is always our independent variable, and it always goes on the horizontal axis. Y is our dependent variable, and it always goes on the vertical axis, the up-down axis. Okay, y is dependent because the value we get for y will depend on what x is. So let's take a look at this table of values. This table of values is the table of values for the relation y equals 3x minus 5. We're going to focus in some of our later lessons on exactly how to take something like y equals 3x minus 5 and get a table of values for it. So for right now, you're just going to have to trust me that this table of values matches this equation. All right, so let's take a quick look at what we usually do when we see a table of values. We look at what's happening to the x values and what's happening to the y values. We want to confirm that this is linear. Remember that in lesson 2, we said if something is linear, it has to have a constant pattern in the x and a constant pattern in the y. So if I look at my increase in x, they're going up by plus 1. My increase in y is going up by plus 3. Okay? So it should already start to make sense to me why the equation starts with y equals 3x, because we always know that whatever y is going up by is going to be attached to our other variable. All right, so now what I want to do is focus on some new vocabulary. How do we take a table of values and get an equation? Okay, we already know how to do that, but we're going to go a little bit more in depth because now instead of dealing with specific patterns, like when we did table and number of people, we're just looking at general x, y values. Okay, so the coefficient in a linear equation is found by dividing the pattern of y and the pattern of x. The coefficient is always the number in front of the x. Okay, so if we look above, if we want to find the coefficient, so we're looking at the table of values, what we're going to do is we're going to take the pattern of the y values first. So the pattern of the y values is plus 3. So we're going to take plus 3, and then we're going to divide it by the pattern of the x values. The pattern of the x values is plus 1. So the coefficient is just 3. Okay? All right. The constant in a linear equation is where the point, where the line crosses the y-axis. So if we are looking at an equation, so let's go back up here. Remember, the y-axis is the up-down axis. So this is my y-axis. I'm just highlighting it so that you know what I'm looking at. What we want to do is take the line, so in my case it's red, on your paper it's black. Where does the red line cross the y-axis, which I just highlighted in orange? I want to see where they cross. So right where I drew that black dot is where the line crosses the y-axis. So I want to ask myself, what is that number? Well, it's -5. So in this case, by looking at the graph, I can see that the constant is -5. Okay? I should also be able to see that this pattern of the y values going up by 3, I can see that on this graph. If I look at what's happening as I go from one point to the next, these keep jumping up by 3. So that's how I can see that the graph also connects with the table. All right. Now what happens if we don't have a graph? How do we figure out the constant if all we have is a table of values? Well, in a table of values, the constant will always be the value where x is 0. So if we go back up here, and I'm going to use orange highlighter again just to match up, I'm going to ask myself, where is x 0? Wherever x is 0, I'm going to find the number that matches that. In this case, it's -5. So I can either tell by looking at the graph that the constant is -5 or by looking at the table of values. So this helps us write an equation for any table of values without having to even graph it. So in linear, an equation can be represented by the following. You take the dependent variable first, which is always the second letter in your table of values. It will equal your coefficient times your independent variable, which is your first value, plus your constant. So another way you can write this, our dependent variable is always y, equals coefficient, our independent variable is always x, plus the constant. These two equations mean the same thing. All I did was change dependent variable to y, and I changed the words independent variable to x, just to match my table of values. Okay, so this sounds a little bit complicated, but we're going to do a few examples, and I think it will make a little bit more sense. Example 1, sketch the graph and write the linear equation. Okay, so if I want to write the linear equation, remember I'm going to do y equals the coefficient times x plus the constant. I'm going to actually write that underneath because I don't have quite enough space there. All I'm doing is copying the formula from the previous page. Okay, so let's start by finding the coefficient. So to find the coefficient, we are going to find the pattern in x and the pattern in y. So our pattern in x, up by 1, up by 1, up by 1. Our pattern in y, down by 2, down by 2, down by 2. So the coefficient in this case, take your change in y, which is -2, divided by your change in x, which is +1. So always, what's the change in the second column? Divided by the change in the first column. -2 divided by 1 is -2. So now let's start writing our equation. Y equals, we now just figured out the coefficient is -2. So instead of coefficient times x, we can write -2 times x. The last thing we have to find is the constant. So if we're working from the table of values, and we're going to do all that first, if we're working from the table of values, the constant is the point on the graph where x is 0. So where x is 0, what is y? That's what we're looking for. So let's go to our table of values and let's find the row where x is 0. Okay, always where x is 0, y is 1. So that means my constant is 1. So y equals -2x plus 1. That's my equation. Okay. Now let's graph this. So we already know how to graph this. We're going to start with that first point when x is -2, y is 5. So again, if you want to, you can take the values from your xy table, and if you prefer, you can write them as points, right? -2, 5, -1, 3, 0, 1, 1, -1. So we're going to first go -2 on the x-axis and 5 on the y-axis. So you should be going backwards 2 and up 5. That's your first point. Your next point is negative 1, 3. So that's backwards 1 and up 3. Your next point is 0, 1. So that means you're not going left or right at all, but you're going up 1. Your next point is 1, negative 1. All right, that is our graph. Okay, let's try B. So we know our equation is going to start with y equals. I'm not going to write the whole template out this time, okay? Let's start looking for our pattern. So our x values are going up by 2, and our y values are also going up by 2. This is why it's important to check the x. When we were doing our word problems back in lesson 1, our first column was usually going up by 1, right? We had 1 table, 2 tables, 3 tables. So we didn't really need to worry about it, and we just decided that the number we would put in front of the x was always going to be whatever the second column was going up by. But that's not the case if your first column is going up by something other than 1. So again, remember what we do to find our coefficient. We start with the change in y, always the change in your second column. So the change in y is plus 2, and we divide it by. So the plus 2 from here is on the top. We divide by the change in x. It just so happens that the change of x is also plus 2. So this is why I'm kind of drawing these arrows, because if I just put in the plus 2's, you might not know which order they're coming from. So 2 divided by 2 is 1. So my coefficient is 1. Okay? Now to find my constant. Remember, to find your constant, you're looking for when x is 0, what is y? Always. So when x is 0, what is y? Well, let's go to our table of values, and let's find where x is 0. When x is 0, y is negative 1. So these are the two numbers I need to use to make my equation. So remember, y equals your coefficient first, so 1x, plus your constant. If your constant's a negative, you could just subtract it. So y equals 1x minus 1. Your other option, you don't need the 1 in front of the x. You could just write x minus 1. Both of these are acceptable. Okay? All right, so before we go ahead and sketch it, what I want to do is talk about what happens if we maybe can't actually see a 0 value. So let's say I take the table of values from above, and I only give you these values here, 2, 1, 4, 3, 6, 5. So I start off by finding the coefficient the exact same way, plus 2, plus 2, plus 2, plus 2. So I can see that my coefficient is 2 over 2, which equals 1. Now, when I go to find my constant, I say to myself, well, I need to figure out what y is when x is 0. And when I look at this table of values, I notice that there isn't an x value of 0. But what I should notice is that I can add in more values. Like for example, if I wanted to, I could continue this table further down. If I wanted to add a number after the 6, it would have to be an 8 in order to fit with the pattern. And then if I wanted to add a number under the y values, if I have to keep going up by 2, it would be 7, right? So I can add to my pattern if I need to find more numbers. The same can be said then for moving backwards. So if I want to add a number in this direction, well, if I'm going backwards, instead of adding 2, I need to subtract 2, which fortunately gets me to 0. That means I have to subtract 2 here, which also gets me negative 1. So I get the same answer. Sometimes, if you don't have the 0 there, you might need to use your pattern to add some more numbers to find it. All right, let's plot these points now. So our first point is x is 0, y is negative 1. Our next point, x is 2, y is 1, x is 4, y is 3. x is 6, and y is 5. Okay, remember when we're drawing our graph here, we're going to connect our lines, we're going to extend, and we're going to make some arrows on them. Okay, so in this lesson, all we are really practicing is, can we take a table of values? Can we find the coefficient and the constant so that we can write an equation? And can we plot the points to make a graph? And again, a reminder, they should be linear because we can see that the table of values has a linear pattern. Moving forward into our other lessons, we will work on making tables of values from equations and doing some word problems, getting a little bit trickier, but for now we just really want to focus on understanding how to use a table of values to get an equation and to graph.